Hello. Good morning. Hi, everyone. Thank you for joining us today for this side event, satellite event. My name is Anca Anghele. I work for the European Space Agency, and I'm together with my colleagues here today. We have Diego, Lubo, and Sara, who are going to support this, this satellite event. So we're talking this morning about creating indicators from Earth observation datasets and using these indicators to produce some storytelling. So to do this, we're going to be working with a tool, a web publication that we developed together with our colleagues in NASA and in JAXA. So today you'll be working with some ESA data, with some NASA data, and with some JAXA data. And you'll learn a little bit about this project and how you can use this open source tool as well. So we'll start with a brief introduction about what this project is about and what the program is going to be. So it's going to be a very short, let's say, presentation from my side, and then I'm going to pass it for the practical side to the team here in the front. And if you have any questions or you want to ask something or you were going too fast or you missed something, just let us know. Okay, so EO dashboard is a dashboard. It's a tool that we developed with our colleagues, as I said, in NASA and JAXA. And what you see here on the screen, and we're going to go through that as well in a demo a little bit later. But what you see is one of the stories that are published on the dashboard with the data that is brought in from various sources. So in this case, okay, it's going a little bit fast, but I'm going to just start it again. So this story talks about the Australian bushfires, and you can explore it by yourself as well on the dashboard. And what it has, what it includes is you'll see a couple of elements. So you have all this storytelling part with the actual information. Oops, I think I changed the slide. With, let's say, with the various sections of your story, including some media elements to support it, and then we have these interactive maps where you can, let's say, communicate something about a phenomenon that happened there. And in this case, for the Australian bushfires, this story speaks about a very large, let's say, extreme fire event that took place in Australia in late season of 2019. And it's using satellite data from tropomi in this case, it's carbon monoxide, because that's a product of burning, right? And it gives us an indication. So if we observe this carbon monoxide plume as it evolves in time, it gives us an indication of the severity, the extent, how long it took this event, and what is the maybe impact going across borders. And because this data sits in various sources and is typically openly accessible through various means, through the various services that each agency provides, then we can also use it in some notebooks. And this is what some of the, what we are going to show you also in the practical part of this tutorial. So just scrolling a little bit back into this story. So here we've embedded also a notebook that uses some of this data to evaluate the impact of fires on populated areas. The example is not necessarily on Australia, but it's using similar data sets or the same data sets to draw some conclusions or to make some analysis. So it goes a little bit beyond just mapping that event and shows you as well what kind of calls you can make to the various APIs that provide this data, what kind of simple, let's say, statistics you can do, but of course you can go beyond that and do more advanced things. Okay, so we try to make all of these resources available openly on the dashboard. So we have a page, and I'm going to walk you through that in a little bit, where we publish the notebooks that we develop, the various links to the tutorials that we make, such as this one. So you're going to find this tutorial as well on the dashboard. And we have a growing list of indicators, and you're going to see in just a minute how those work. But essentially, all of these resources are free to use. You can use them for yourself, or you can use them for your educational project if you're involved in something like this. We feature on this dashboard some stories that are created by scientists from the three agencies, so from ESA, NASA, and JAXA. Essentially, they are curated content, let's say, coming from the projects that we fund, from the scientific activities. But it's not limited to that, just these contributions. So we can also feature pieces of research that are interesting and that, let's say, tell a story that is useful for society, that comes from the community, so from people like you, or from researchers in general. It doesn't matter what level career you're in currently. So the main idea, let's say, for these stories is to have some sort of societal relevance. So it's not necessary. It is a scientific communication tool, but it needs to speak to the general public. So we try to present the information in a way that is accessible, we always look for new ways for how to do that. Because as scientists, sometimes we typically go to a language that is not so obvious to the general public. So it's good to have this more, let's say, citizen-oriented approach. Okay, so this is what you will be working with, and some of the tools that are behind this dashboard. So we hope that you're going to learn something about this project. You're going to explore using this for your own purpose or for teaching others. Maybe meet somebody new and have a good time. And this is our social media hashtag if you want to talk about it. Okay, so this is the agenda. We are in the middle of the first part, so I'm currently giving you this overview of the project, and there will be also a short demo. It's going to be about 30 minutes, maybe a little bit less. And then we're going to go into the indicator production. So you're going to see how these indicators are produced and create some of your own on a guided manner. So we make available a notebook that you're going to be running alongside with us. So we're going to do a little bit of a setup check right after this presentation to see that everybody has the proper access, and if not, then to register you and give you access to this. And there will be a coffee break at 10:30. And then we're going to pass to the second part, where these indicators that you've produced, we're going to bring them on the dashboard. So you're going to see how we're going to do that, how you can do that by yourselves using the open source tools that are available. And then how we're going to use these indicators to create a story with them. Okay, you will be needing, if you're not registered yet, you will need a GitHub account. So if you don't have a GitHub account and you haven't registered yet, you have the chance to do that now before the practical part. Okay. So I spoke a little bit about this collaboration between the three agencies, between ESA, NASA, and JAXA. So we started to work together during COVID, and we asked the question, can we see impacts from COVID from satellite data? And there was a lot of effort to find what are the relevant data sets. Can we see something that's not in very high resolution data? Because many people were looking at things like how many cars are parked in a parking lot, if the shopping centers are empty, and things like that. But we saw that we can also track some changes, environmental changes, also from open data, so from Sentinel's data in particular, because this is the, let's say, most accessible one. And there were quite some interesting results, especially on air pollution, on water quality, and many other aspects. So while initially we started with COVID, then we extended this analysis because COVID was kind of under control at some point, so it didn't, we couldn't observe these changes anymore. So the curfew was off, right? So we expanded this analysis to other areas. So asking a generic question, what kind of value do we get? Or do we get more value if we bring together data from the three agencies? Because none of the agencies by itself has all the capability to observe everything, right? So we said, okay, we have complementary sensors, we have complementary missions. Let's try to see if we use these missions together, can we observe more than if we do it in isolation? So we extended this to cover a few areas, so atmosphere, agriculture, cryosphere, oceans, biomass, economy, and we added also extreme events recently, as we know that these are becoming more frequent and more impactful. So it's a, let's say, very hot topic now. Okay, and if you want to see how it went during COVID, you can scan this QR. It's a link to a video that presents the vision from the 3 directors of the agencies about this project. So we did a lot of things in the meantime because 5 years have passed, almost. So starting from 2020, we were a very big team, and you see that big picture with lots of faces on it. So it shows the kind of effort that was invested in the beginning. We were all kind of very mobilized to try to do something quickly for COVID, and we came up with the first version of the dashboard that looked like that. It's this part here, and it was really very much accessed from all over the world, and this was kind of a big success. So then we decided to organize a hackathon, and we collaborated with the team that is organizing the NASA Space Apps. I don't know if you're participating in those or you know about them, but they're actually, I think it's in 2 weeks or in 1 week, this next edition of the NASA Space Apps. So it's a global hackathon, and it was quite successful again. So because we continued the collaboration, and we showed some nice results. We got this award from IAF on Space for Climate Protection in 2023, and that's when we switched, let's say, to this new type of interface with a little bit more focus on storytelling. It's when we introduced actually the storytelling part. And recently, so from 24, 25, we started to open it for community contributions. And we do this typically by collaborating with universities. So where we have students, master students or PhD students that are learning Earth observation and want to, they have some small results that they can showcase on this dashboard. There's a lot of community outreach, and we're happy to collaborate with the community. So if you're interested to bring this to your classroom or to your community, we can have something that's dedicated for you. But we're usually present in all of the big events, like EGU, like IGARS, LPS, Living Planet Symposium. We were there also this year. And we do a lot of training with this. So what kind of data is on the dashboard? The dashboard is not necessarily a tool like the Copernicus data space ecosystem, right? So it's not, the aim is not to give you access to Earth observation data, but rather to showcase indicators, like value-added indicators from Earth observation data, built from Earth observation data. So there's virtually no limit as to what can go into the dashboard, as long as it is based on data that comes from ESA or from NASA or from JAXA. And it covers one of these societal relevant domains, right? But it has to be a value-added product. So you can see there are many missions that are contributing here, and the types of global data sets. So really the variety is quite large. We cover all of these domains. So we have all of the atmospheric products, like the carbon dioxide. This is from NASA, because ESA doesn't currently have such a mission. We have the NO2, nitrogen dioxide, which is the one that's that we looked at for air pollution during COVID as well. We have data based on SAR data, based on optical data, a lot of very different indicators from agriculture, but also on the cryosphere. So we have how the melt is starting and ending, for example, in Antarctica, based on Sentinel-1 data. So really, it's really heterogeneous, and we don't try to be, let's say, comprehensive, but we do want to communicate to the public. So the scope, in the end, is kind of twofold. First, to show that bringing data from ESA, NASA, JAXA together is more valuable than working with just one agency's data. And second, to show what we can see in terms of environmental changes and communicate this to the public. So storytelling is the big part there. Okay, let's see if I can make this live rather than Okay. So the dashboard is accessible. Am I on full screen? It's accessible at eodashboard.org. Okay, if you want to go to it now, you can just scroll this. It works best on desktop, but you should be able to use it on mobile as well. But the experience is best on a larger screen. So this is the homepage. We have on the homepage a little bit of introduction of what this project is about. And then we have a bunch of stories that are grouped per thematic. So there's agriculture, atmosphere, biomass, some stories on COVID, cryo, economy. Okay, this one has a missing picture, extreme events, oceans, and so forth. So each of these stories is built. I'm going to click on this one that you saw in the earlier example. Each story is built with all of these elements that I've presented before. So you have a mixture of text that actually tells you what the story is about, some media, you can interact with it if you want, you can move from one to the other, some information about the mission data that was used, so the science mission data, and then links to some of the data sets, and the interactive map. And here, again, we can have this storytelling approach where you browse through dates and try to explain what happened there. Okay, so how do we create these stories? So to have these stories, first of all, we need to have this data populated into the dashboard. So to reach the dashboard interface, you can just click this button here that says dashboard. And you can just select one indicator to add to the map. So I'm going to add one air quality indicator because this one is very nice to look at. And I can go back to that COVID example to show you the change globally. So this is an indicator that is coming from Tropomi. It's the tropospheric nitrogen dioxide concentration. This is an ESA emission, of course, and for each indicators we have some metadata associated. So a little bit of description of what this tropospheric NO2 concentrations mean, how they can be interpreted, and visualized, and so forth. A link to the providers. This data comes from Copernicus, of course. Some of the assets related to this indicator, which may be additional links, or if you have any sort of another asset associated with it. In this case, we have the legend here as well, and any other relevant information. Okay, so on the left side, you have these controls for the map. So you can change what layers you're looking at. In this case, we don't have too many different layers, so we just have one data layer. You can browse through dates and observe the legend. There are different ways of browsing through the dates. You can play with opacities. And you can change the base layers if you want. You can switch to OpenStreetMap, the EOX cloudless layer if you want the Sentinel-2 based base map, or this default one, which is the terrain light. And for some of those indicators that sit behind an API or a service that allows you to compute some statistics on top of them, we offer this option as well. So, okay, I'm going to go here because here we're going to see a lot of changes. So you have the option to draw an area. I'm going to draw a small area here and just select a date, start date and an end date, and send a request to that API to produce some statistics. In this case, the request goes to the Sentinel hub that gives us the minimum value, the maximum, the standard deviation, and the median. So you can observe these changes over time, and you can click on a point on the map, on the chart, sorry, and it loads the corresponding data or a different one just to see the differences. Okay, so if you want to so assuming that you have produced this data, you brought it into the dashboard, now you want to use it in a story to talk about something, one way to do that, and you're going to see more in what Lubo and Sara are going to show you, is to, oh, sorry, clicked the wrong one, is to make use of this tool that is here, which is called Extract Storytelling Configuration. So essentially, this gives you a little bit of code that you can copy-paste into a markdown-based tool that will help you to create this, this story. So I'm not going to show you how this works because this is going to be part of your practical part. Okay. I forgot to show you something. So other things that we have on this website is a section that's on news and updates. So here you can see what we're working on, if there's any upcoming training or tutorial, and typically we have events such as this one. We have the resources page where you have the notebooks that are available in the stories, list of publications, the tutorials, workshops, and so forth, and some links to the documentation. You can access the data collection, so the stack catalog, as well as the notebooks, the dashboard, and this about page that describes a little bit what the project is about and how you can contribute if you're an external contributor. Okay, so just recalling a little bit what is supporting this. From ESA, we have, all of the 3 agencies put together data. So they make this data available. They contribute with in-kind expertise. So we have a science team that is supporting this. There's some infrastructure behind. So NASA has a system that is called VEDA. ESA has the Eurodata Cube, so in particular the EOX hub contribution. There are some services such as Sentinel Hub, for example, that we're using that are also contributing to the Copernicus data space, right? And JAXA has the Earth Graphy. Okay. Just a little bit of promotion about these workshops that we do with universities. They are called the Science Hub Challenges. So I mentioned that to bring community contributions, we sometimes work with universities. So how that works is that we have a call every year, and the current call is actually open, so this is why I wanted to bring this up. But we have a call every year where universities that have PhD programs or master programs, they can apply to come to ESRIN for a week with about 15 students. And the students are, they meet mission managers, so the managers of ESA missions, they meet scientists, they get all these presentations, but we also give them a challenge, meaning that we pose some data science challenge and they have to solve it with Earth observation data, using one of the platforms that we make available for them. And then if their solution is nice and interesting and has some societal relevance, then we ask them to prepare a story to be featured on the dashboard. So their little project becomes a story on the dashboard. And this is one picture from the group that came from Sorbonne, from Paris, last year. Okay, so the call is open here if you want to apply with your university or you have your group or you yourself are a PhD student and would like to suggest to your professor to make an application. It's open until the 24th of October, so you still have some time to apply. Okay, I'm going to end with 2 more things. First, if you want to be updated on what happens on the dashboard and other things that we do on Open Science, we have a newsletter, so if you want to subscribe, you can do it with this QR code. And then if you want to use the tools that we're showing you today, again, this is an open source project. It's called EODASH. It's part of this Earth observation ecosystem. that's developed by EOX, and that's powering many different projects. So it's not just your dashboard that's benefiting from this, but there are also other activities funded by ESA, funded by the European Commission, that are benefiting from this, that are using this open source project. So I invite you to have a look at it and maybe want to use it. And then if you would like to have an instance of this kind of dashboard deployed for your own needs or for your own project, you can do that with sponsoring from ESA. So this project is available on the network of resources. And I'm going to show you very quickly what the network of resources is about. Again, maybe I can do this. So ESA has a mechanism to provide funding for research purposes. You don't get the actual money, but you do get access to the resources, like cloud computing resources to do your research. I'm not sharing the right stuff, actually, sorry. Yeah. Here it is, okay. This mechanism is called network of resources. If you just Google ESA network of resources, you should be able to get here. But essentially what it is you have a portfolio of services that you can browse through. It's typically access to cloud computing, as well as, so provided by platforms that sit close to the data. So this dashboard is provided by, oops. Yeah, okay, you're here. By EOX. So you can ask for sponsoring to get such an instance deployed, and then the team will help you to configure it and to have your own instantiation. And there's this, in case you missed it, I clicked on this thing that says pricing wizard. So you can see, you can find it in this list somewhere. Here it is, this dashboard as a service thing. And then you just select it and you export this form and send it to ESA, and typically you get sponsoring. If your request is below 5,000 euro, then it gets approved within a week. So you have this possibility if you want to have it for your own project or with your own data. Yeah, so not with data coming from necessarily from ESA. Okay, I think that's it from my side. Do you guys have any curiosity or any question? Okay, we're all excited to go to the practical part. Good, then I guess I invite Diego to the scene. Yeah, thank you.
Okay, perfect. Hi everyone, I'm Diego Moglioni, supporting this project with respect to the AI and data engineering topics. And together with you, I'm going to show how to prepare the data that we are going to integrate into the dashboard as introduced by Anka in order to then combine them and produce an indicator, a final indicator. So we will go through what could be your own workflow of analyzing or integrating different kind of data sources and post-processing them in order to analyze some particular topic that you or your research group would be interested in. But before kicking off, I mean, I would like to understand also if every one of you has got access to the workspace. And here I put also the URL to it that we prepared, available on the GitHub repo of this tutorial. So if you then click here and you access to this URL, you will be directed to the UX Hub that actually integrates the different tools that we are going to use for this tutorial. And once you click on the Example Explorer, here you see the different resources and notebooks available. And in this case, we are interested in this one, the Urban Health and Megacities, the case of New Delhi. And by clicking on the rocket icon here, you spawn the corresponding environment. So tell me if everything runs smoothly by your side, if you were able to sign in and to spawn your environment. But also my colleagues, Lubo and Tina, are in the room in case you got any issue. But before starting, please give me some feedback if you were able to spawn the environment, so you can follow along and run the notebook together with me. Yes, please. Hi. I said awaiting approval. Okay. Any other issue? Great. So we're good to go. Okay, once, as said, once you click on the rocket icon here, you spawn the corresponding environment. You will be directed to the actual notebook that we are going to run together. So in this case, as written in the title, we are going to analyze the urban health and how it is affected by different kind of issues that could appear. That could be in terms of pollution or heat waves that actually took place in New Delhi and the neighboring cities. That will be the focus of this investigation that we are going to pursue together. Here you see that in this image, there is the summary of the different case studies that the notebook is divided into. That actually pertains the analysis of, in the first case study, on the impact of COVID and how it impacted, in particular, the social activity. And we will be using data coming from NESA to produce a nightless map to analyze the spatial pattern of this impact during the night. Case study 2, the air quality, by using data coming from the Sentinel-5P ESA mission and the Tropomi instrument in particular. Case study 3, the heat wave, by using data from the Japanese Space Agency, JAXA. And finally, case study 4, the urban vulnerability, by using the GRDI index and the NESA data. As you saw, as introduced by Anka, EU Dashboard integrates the effort of the 3 space agencies. So, and this notebook actually resembles that, combining different data products coming from the different agencies together. Here you see in this description the running environment. I provided you with also with a YAML file that you can actually browse in the directory structure that you see here on the left. And basically, this is already pre-installed in your workspace, but here you have also the YAML file so that you can reproduce this environment on your own machine. And you see also the directory structure with the different use case that have each a specific directory that they are referring to. Okay, so use case number 1. As introduced, we are going to analyze the impact of COVID in terms of social activity and focusing on India, in particular northern India, in the time period 2019-2022. And we're going to produce this nightlights map that is a spatial, in order to assess the spatial pattern of night lights, to understand how or use this kind of indicator as a proxy for the social activity. So what we are going to then to obtain is this kind of map in which the different colors of the channels mixed together represent an increase, a decrease of the social activity, using as a proxy the variation of lights. So this activity and this work has been carried on by Professor Tojo in cooperation and sponsored by JAXA, by using this SWAMI MPP input data. And coming to it, here are a couple of words about the input data and what we are going to use. So we are referring, and we will be using the data coming from the BiDS' sensor, which is a radiometer, and aboard the SWAMI MPP mission. And this data has been corrected to compensate for lunar glare already, so that it is improved in terms of reliability as well in analyzing the phenomenon in consideration here. So what this product has been then obtained by aggregating this raw data coming from the sensor in a semi-annual basis. So we are going to find the first half of 1 year and the second half of that year. And why? Because for higher latitudes, for example, above 50 degrees, there are gaps in the data. And so in order to compensate for that, they've been aggregated, and the median has been calculated on a semi-annual basis. This will be the input of our use case. The spatial resolution is about 0.5, 0.8 kilometers, 464 meters at the equator, and the metric we are interested in is the nighttime radiance. As said, the data is available for this use case locally under the Nightlights directory, since JAXA shared this data and is available here to be used for the use case. In particular, here I put the image of the tiling scheme for BiDS', and we're going to refer to the tile of northern India, the focus of this analysis. So let's go. Let's run the first cell here. Here we import in all the libraries necessary to run the notebook. And we are going to define the input folders. Here, as I mentioned, the night lights, which actually contains the input for this use case, that are GeoTIFF files containing the median aggregated data as explained. But before analyzing and post-processing them, let's analyze visually what this data is about, what this data looks like. So we're going to run the visualization part, and we're going to plot the corresponding figures. As you see here, there are two columns. On the left-hand side, the first half of the year from 2019 to 2022. And on the right-hand side, the second half of the year, again in the same time period. Here are the median nighttime light level in watts per square centimeters per steradians. Now what we want to do is applying a color blending technique to actually assess quantitatively the spatial pattern that we are observing throughout the year. And this is actually the purpose of these cells here below. So we are going to mix the three bands of the images, are the RGB channels, in order to obtain different shades from red to blue that indicates a decrease and increase in the intensity of light, used as a proxy for social activity variation. In particular, we are going to assign to the red band the maximum pixel value for 2019. We're going then to assign to the green band the minimum pixel value between 2020 and 2021. And finally, to the blue band, the blue channel, we are going to assign the maximum for year 2022. And we are going to obtain as output different regions with different spatial patterns that we are going now to analyze. So, first thing first, we are going then to explore to retrieve from the input folder the data that we actually need. So we're going to run this cell like that. And we are going to group the files in first and second half of the year in order to be ready to apply the blending logic that I explained before. So we run this cell here. Okay, now we actually apply this pattern and the corresponding blending here. Here you see the blended image created applies the scheme and the logic by extracting the maximum, minimum, and then the maximum for the different years. So now what we're going to do is applying a particular stretching. What does it mean? It means that we are going to emphasize the corresponding channels with the bands, focusing on, in this case, the urban nighttime levels. And then it has been obtained from the Professor Dojo's study that in order to do that, we can adjust each band range between 25 and 1000 radians level. In this way, with these values, we can emphasize the brighter areas of the image. And this function here applies exactly this approach with the value that I explained you right now. Of course, these values can be modified, and afterwards we will be seeing what kind of stretching we could use as well. We apply the blending and the stretching to the image, and then we plot the corresponding map. As you see here, we obtain different kind of of areas, white, reddish, and bluish. But in order to understand better what's going on, we are going to overlay this map on geographically, so we understand also exactly where we are. So in order to do that, we run this cell here, in which the corresponding output that we just produced and that you can find here under the output directory is then converted to a cloud optimized file, ready also for the integration to the dashboard, as we will be seeing afterwards. And then we extract, of course, the coordinate of the geographical area. We apply the transparency channel to the image in order to be superimposed to the map. And then we overlay the results with an OpenStreetMap. As you see here, we are in northern India, in particular in New Delhi area. And you see here the spatial patterns of the different areas covered. A white or grayish level indicates no significant variation from in the time period that we analyzed. Whereas a pinkish or a reddish variation shows a decrease in social activity or presumed decrease in social activity, whereas the bluish and violet part indicates an increase in this corresponding social activity. We're going also to better understand this and analyze that when we produce also the corresponding story out of these results. As mentioned before, there are also alternative stretching approaches to emphasize, for example, rural area instead of urban areas. And here I put also the different levels in terms of radiance that you could apply to that function. So you can tweak that stretching function showed in that cell to analyze or emphasize rural area. And there is also a general or broader focus that uses a log transformation applied to the different bands. That here as well, you got the different values. So this kind of approach has got also different kind of applications. So I invite also you to actually translate this kind of assessment to your use case, for example. And this here is a list of the different applications that this kind of approach could be applied to, from disaster recovery to energy and monitoring of illegal activities. Okay. Here I put also other links to the reference of the Professor Dojo's study that you can browse yourself. So here we are for use case number 2. So use case number 1, we use NASA data and the product developed by Jackson. Then we produced that map as a cloud optimized file. And now we are interested in analyzing, again, in India, the air pollution. And we are going to do that because in particular in northern India, is prone to this kind of issue for a number of reasons, from vehicle emission to crop stubble burning. And all these factors contribute to the degradation of the air quality, as, for example, showed in this image. So we are interested in assessing also statistically this kind of event to see if there was actually an anomaly in the air pollution, and we will be using nitrogen dioxide concentrations to assess that, coming from troponin instrument of Sentinel-5P. In particular, we will be generating a time series of the mean values for the NO2, together with the standard deviation to assess if there was, in fact, an anomaly there. You can also browse, as showed by Anka, the NO2 data on the dashboard under the air quality theme. So the input data, tropospheric nitrogen dioxide, as said, coming from the troponin spectrometer. The aggregation has been done to cover 14 days and averaging them in that interval to actually averaging out the daily variations due to the weather. The spectral band are from the ultraviolet, near infrared, and shortwave infrared with the resolution 7 by 3.5 kilometers. The metric that we are going to analyze is the micromoles per square meter. And the data access is actually a custom collection or bring your own COG collection, data collection, available and to be accessed on Sentinel Hub that we are going to see in a moment. Again, in this cell we import the Python libraries. And first thing first, we analyze where we are. In that case, we're going to focus on, instead of New Delhi, in a neighboring city, Gurugram, southwest of New Delhi. So we draw actually the bounding box of the area that our studies focus on. We are actually here. Now, as mentioned, for the data access, this data collection in particular is available as a bring your own COG data collection on Sentinel Hub. And in order to produce or to assess the anomaly on NO2 concentrations, we are going to use this Sentinel Hub statistical API, which requires all these input listed here, from the area of interest, the time period that we are going to analyze, the end of 2024, in which, in particular, an anomaly has been detected. The data collection that we need. In this case, we need the collection ID in order to query the Sentinel Hub server. And this ID is available and accessible on the, as well on the stack catalog that Anka showed you before, that actually contains different metadata and also this kind of information as well. Here in the notebook, I also put an example of how to query the EO- stack catalog and in order to retrieve different kind of metadata and the collection ID as well. So you can replicate this kind of example on your own afterwards to understand how the data is structured. Each indicator basically is a stack module representing the data collection. So, again, here. Another thing that we need is the eval script or custom script, which is actually a JavaScript code, which we are going to introduce to inject the logic on how we are going to process satellite data and what kind of values the service, the Sentinel Hub services should return. Here again, you got the link to the documentation on Sentinel Hub that you can browse for further details. And then the statistics that we are going to compute, mean and standard deviation in that case. And we will be returning with an API response in JSON format that we're going to parse to extract this information. Additional information here also under this link to the Sentinel Hub documentation. In this cell, we are going to then define the first batch of the input as explained, the bounding box, previously defined to visualize the area. the time interval, end of 2024, in particular from the 1st of November until end of February 2025, and the data collection ID that I put here for brevity, but you can also access this information by querying the stack catalog, as mentioned before. And now we are ready to define the other input parameter that I described, the eval script, which is actually basically composed by two functions. The setup, where we specify the input and outputs, and the evaluate pixel that actually computes the output for each pixel. It is mandatory also for the evaluate pixel function to return a data mask, in which we filter out unwanted data or outliers. And here we are. This is the cell defining the eval script with the two functions setup and evaluate pixel. And then we are ready now to build the NO2, the request to the NO2 data collection using Sentinel Hub statistical API. We build the data request with the inputs that we defined above in terms of, as you see here, bounding box, data collection, the eval script, and the time interval. We're almost there. The other step is now setting the credentials to access the Sentinel Hub services. Sentinel Hub uses authorization credentials to access its services, and here we already put the credentials under the environment that you spawned, but you can actually generate your own credentials by following the instructions that I put here in this comment under this cell. We are going to create a session now with the service URL we are going to connect to, which is the Sentinel Hub service endpoint. And we actually generate the corresponding token, being now ready to send the POST request to the server. As you see, the server exposes the statistics API under this URL. And this is the response that we get by sending the POST request. As an input, we inject the statistical URL service, the header, and the data request in a JSON format. We run this cell, and we actually obtain the response that we are going to now parse in order to extract what we need. And this is done by running this cell, in which we extract in particular after we parse the response here in this instruction. We are going to extract then the time axis, the mean, and the standard deviation in the selected period. We run this cell, and we are finally ready to plot the NO2 time series to assess if there was in fact an anomaly in 2024. Here is the plot that we obtained, which represents the time series that we extracted from the 1st of November 2024 until end of February 2025. It appears there was a spike actually by the end of the year, in December in particular, with NO2 concentrations value rising from November and peaking in December. We also see by these vertical lines the actual standard deviation that increased over that period of time, representing, so in fact, an anomaly in the NO2 concentrations level. So with this use case, we actually analyze the impact of air pollution over New Delhi and its surroundings, in particular Gurugram. And we use Sentinel-5 ESA satellites in order to analyze quantitatively the data, in particular coming from the Tropomi instrument. There is not only the nitrogen dioxide parameter to be monitored out of Tropomi. It has, the spectrometer has or can map other gases as well. And here I put you an example of the other gases that the instrument can monitor. So from ozone to methane, carbon monoxide, that are all affecting our health and our climate as well. So we came to the end of use case 2 as well, and now my colleague Sarah will guide through the use case 3 and 4 to further analyze the impact on social activities. Thank you. Questions so far? You were able to run the notebook together with me? Okay, great. Yeah. Oh, sorry. Oh, okay. Yeah. Yes. Not yet. We now what we actually were going through is something that resembles or could resemble your own work. I mean, this is a workflow that you got on your own with your post-processed data and the product that you obtain out of raw data. And then you want to combine different kind of data coming from different missions to analyze a particular aspect. In that case, we are analyzing the health over mega cities. And afterwards, then you want to integrate all the outputs that you obtain into the dashboard. So we are in the stage 1, in which we are reproducing your own workflow, and then the output that you produce, then they are going to be injected or ingested in the dashboard. And this will be the focus then of my colleague, Lubo in particular, after the ending of these use cases. Okay, thank you.
Thank you. Just to be sure we are on track, at 10:30 we'll have the coffee break, right? So I will introduce you now the 2 last use cases, and then at the end of the session, I will also come back again so I can help you build from scratch a storytelling of all of this process and also how to interpret all that we have created. So the use case 3 is about heat waves. In 2024, it was a particularly bad year in the northern India because there was several problems related to record-breaking temperatures. There are, on the news, we could see that there were dozens of thousands of heat strokes across the country, and not only this is important to look at, not only for the health perspective, but this also put a lot of pressure on the power grid because of the cooling system. So this is something, heat waves in general, something that goes beyond urban health, but also the actual health of the urban city. So for this use case, we are going to look at land surface temperature using the GCOM-C satellite from JAXA. It has a sensor on board that allows to retrieve information on the thermal part of the electromagnetic spectrum, which is what allows us to retrieve the land surface temperature. This data set specifically that we are going to use is a level 3 product, and it's aggregated over an entire month. So although the heat waves were across from May to July in 2024, we are going to look only to 1 full month. And what is the end goal? We are just going to apply a threshold on a specific temperature that one could define as a heat wave and try to understand locations within the northern part of India that were specifically hit by these high temperatures. So we import the libraries that are needed for this case. We created also the folders. We always follow the same structure. So here on the side, you'll see the dedicated folder for this use case. And regarding the access to this dataset, so it is hosted by JAXA gPortal. And in this case, it's an easier task since it does not require authentication. So if you click here, it will take you to this page. It will take you to this page. This is an example for another data set. Here you can collect the data endpoint from where you can directly call a direct ITTP access, so you can store locally this COG file into your machine. So in this case, this is what we do in the cell. So we are accessing directly. We save it as a LST TIFF. It goes and gets saved in our folder. And then we will plot this image. Before, since this is a TIFF file, we are opening with GDAL, since it's better for dealing with raster data. And we convert it into a NumPy array because we are going to apply a mask on it and doing some calculations later. So we hit press and we see what it got. So we don't like this because it's far from India and this data set needs some cleaning. First of all, we need to take care of non-values. We need to crop this data to our area of interest and we need to convert this to Celsius. So after some investigation on the specs of this data set that you can see in the input data information, we see this as a scaling factor of 0.02 and it was in Kelvin. So we simply convert the NumPy array created before, we convert it into Celsius, and also we mask these values that do not make sense on the natural world, but sometimes we have these artifacts when we are collecting data with satellites. So we define two areas of interest, Northern India and New Delhi. We specify the bounding box of these two big regions, and we are storing we are cropping the Northern India into this variable, rcrop India, and another one in rcrop Delhi. You later use this and change to see the different visualizations using the different arrays. Then we plot the results after some cleaning, and we here selected the color scheme as plasma, but you could use, for instance, Inferno or something just to see how it looks. But in this case, we are using plasma, so it matches the one that we have ingested as visualization on the Sentinel hub. So for the sake of equal visualizations. So I'm going to put it back to plasma because it's nicer for visualization purposes. Plasma. Okay, so here now the data set is cleaned. I have a big overview of India and I see this particularly high hills with over 50 degrees Celsius, and here is a crop area around the region of New Delhi. And you can see also, mind you, this is an average of monthly temperatures of July. You can see this is, we can see here values of around 40 something average of a month. This is no joke. And according to the definition of a heat wave, can be either above 5 degrees over of normal temperature over a period of time, or it can also be defined as locations with 40 degrees And in the case of India Meteorological Institute, they define heat wave as locations with 40 degrees, if in cities, or 37 degrees around coastal areas, or 30 around hilly areas. So for this reason, let's play a bit and see what happens. So here, the threshold that we are going to apply to this NumPy array is 40. Let's start easy, so not so constrained. We define here, we select the AOI, and let's start for the New Delhi one. So change here, if it's in the notebook, it's the New India. Start with the New Delhi one just to see this location of this megacity. And then we plot. Okay. As you can see, in this boundary box around the region of New Delhi, you can see that there was these certainly average during a month temperatures of above 40 degrees. And since it's a NumPy array, you can also just make an easy calculation and even estimate the amount of areas that were vulnerable to this. But now let's take another look on India. So change here India. And let's be even more restrictive. Let's apply a threshold of 37 degrees Celsius to see what happened. And yes, it's again, data visualization can be susceptible to numerous interpretations. And in this case, since we are talking about a monthly average, probably we are overlooking days with lower temperature and so on. So we have also to be careful how we interpret these results. So now we will move to our last use case, which is about assessing deprivation and poverty and New Delhi and Gurugram. Why are we comparing New Delhi and Gurugram? First of all, we already mentioned Gurugram in this notebook because of these high temperatures, these high concentrations in December of 2024, but because these two cities are close to each other, but they are completely different. New Delhi is the capital. It's home to 30 million people. It has a very diverse demographic and urban fabric. It has infrastructures well settled, and but also settlements. On the other side, we have Gurugram, which has become a corporate hub, or financial hub of the country, and has developed drastically over the past years. So for this reason, we are going to look actually into the shape of these cities and try to use this indicator that tells us about deprivation and poverty average in the administrative boundary of the city. This could be, for instance, interesting for decision makers when they want to create new rules, for instance, on their cities. About this actual indicator, this is based on 6 other indicators. 2 of them are satellite-based. So one of them is based on night lights again. The other one is a slope, or how the night lights progressed in the span of 2022 and 2020. But we also have this combination of other information that does not come from satellite, which makes this indicator very interesting. It comes from NASA, this one, from the Socioeconomic Data and Application Center, SEDAC. And we are going to look not only at the GRD indicator as a whole, but we also will look into one of these other indicators that enables to create this indicator. And let's see what we would expect. So the input data, it's global. If you click here, you can have a look how it looks like. It's already ingested on your dashboard. We can have a look. And why I'm showing this, because for you to have an understanding that this indicator spans from 0 to 100, 0 meaning high deprivation and poverty, and the maximum is lower deprivation and poverty. So for the data access of this one, we are using, it's not as straightforward as the use case before where we had the data sitting into a data endpoint, but here we have to go around because the data of this indicator, the COG is not publicly available. However, the vetted tile endpoints allow to publicly access these satellite and abstracting all the complexity with S3 authentication. So we don't need to care about creating a token or auth to authenticate, because this is what NASA VED allows us to do. And this is what we are going to do. So first we can query the stack catalog. So if you read, which this is where it stored all the collections. If you uncomment here, which I will not tell you to do right away, but we'll do it later. If you uncomment here, you can actually see all the collections stored in this catalog. But no need for now. And the collection ID that we are going to use to see in first place is the GRDI. So I will go back just to remind you, GRDI is one single indicator that's a combination of these 6. So for now, we are going to check only this one. We go back. So we select this one. Here already I left this commented, so you can just copy paste to see how the others look, but let's wait a bit. Now we query the stack endpoint with our selected collection. Sorry, so I need to run. Then you do a preview of the data. And here it's what I mentioned before. We are going to use a tile endpoint to visualize this, because in this case, S3 path is not publicly available, but it's enabled by the vetted tile endpoint. So it basically generates a map out of the COG. And then from there we create an image. Then we can then also do the same as before. So we run this cell. And here we have a bit overview around the area of New Delhi. From here, it's not very intuitive what is the actual meaning of these colors, right? So darker means higher deprivation, lower deprivation, and higher and lighter colors means the opposite. Anyone guesses from 0 to 100 what is the deprivation index in New Delhi, which is here? Can anyone have a sense looking at this? A number. Sorry? 7. Okay. I will not answer yet. You will plot it. But I'm asking this because when the first time I was looking to this data set and comparing this to other European cities, for instance, you can all see this dark color. So I was assuming, oh, it's doing pretty well because it's very low. But this is just food for thought. Now, we are going to compare New Delhi and Gurugram, also known as the Millennium City, because of all this growth in terms of corporate and financial hub in the past years. So we define here the coordinates around these cities. And here I also left commented some other cities that you can play later on, but let's not go for it. Now we fetch the cog into a tile. And here we are cropping our I'm going to zoom out a bit. So here we plot the GRDI within the city boundaries. And in red is New Delhi, and in blue is Gurugram. And here we are going to actually estimate the average within this polygon to see how different or not they might be. And here we plot into graphs this to be easier to compare between these two cities. So, as you can see, this is the result. It's around 50 for these two cities. So, although they are so different in terms of socioeconomic factors and also the urban fabric itself, they seem to have both of them a very, let's say, moderate deprivation and poverty index. We don't know what's behind because this can be linked to multiple things. And now we can, here we can export also our graph that we can use on the story later when we plot the satellite imagery, and then we discuss about these interesting results. So let's go back out of curiosity into the place where we define the collection ID, and instead of calling this one, so go to point 4.4, instead of calling the GRDI file, let's call the GRDI VNL slope raster. This is the one that is based on nighttime, the progression of nighttime lights between 2012 and 2020, just to see if they are different. And then you just hit run all the way till the end, and you see the results. Interesting, no? In this case, the higher values of this particular VNL slope indicate decreasing deprivation. And here there is a considerable difference between Gurugram and New Delhi. And it's surprising that despite Gurugram being a city of innovation, perhaps all this growth happened before 2012, or also this city being a financial corporate hub, perhaps it doesn't have as much as nighttime activities as a city, the capital of India. However, we can discuss more about this and tell this story in later on a storytelling narrative editor. So I conclude like this the last use case. Time for coffee. Or questions, time for questions. No? Okay. So again, we are back at 11, and yes, see you soon.
Welcome back. I hope your coffee break was good. Mine was. And now let's get back to the program, which would mean we are done with generating data into in the workspace. Our indicator is finished. We have two outputs actually that we will work with. One was the cloud-optimized geotiffs of the night lights for area of New Delhi. Second was the land surface temperature, which is also part of our outputs. This data for 1 month for the whole world. Now, I will need to get a bit of information from you, how much you know about STAC, Spatio-Temporal Asset Catalog. The question needs to be concrete though, to get some attention. Please raise a hand if you've heard about it. We have roughly half of the audience, so I will take a bit of introduction into the concepts that we will need a bit later before I delve in what you see in the screen for the actual work. And also I will show how EODASH ecosystem goes around with it. Spatio-temporal asset catalog is and APIs is a way to catalog Earth observation data with some time aspect. We have basically three entities, and that is a catalog, a collection, and an item, and it usually has a lot of assets. The catalog is just a holding entity for a lot of collections. One example of a catalog is the trilateral catalog, so the eo-board.org, the one that powers it. A collection has items. A collection here would be, for example, NO2 daily data. And item is one time entry of this collection with a certain area that it covers and some actual data files attached to it or connected to it, which are called assets. And those would be your TIFF files. So this is the usual hierarchy for static catalogs. And roughly the same hierarchy also applies for APIs, stack APIs. The one you've been interfacing with in the Sarah's session, the Veda API, is an actual API which allows you to query for date time, for a bounding box, so just get me items in a certain area or in a certain time range. Static catalog is what powers eo-board.org, and that does not allow any query. It just gives you everything. You load a catalog, you have all collections, you load collection, you get all items. So it is not that performant for large collections, obviously. The client needs to load absolutely everything. There is no paging concept. But the advantage is that you can host your catalog as a static files on any storage you can think of. We, for example, host our catalogs on GitHub Pages, so a free hosting place. And how EODASH comes in? EODASH is an ecosystem composed of a web client, so the one that runs eo-board.org dashboard, as you've seen, and the whole catalog builder that takes different endpoints, endpoint types, and composes a stack collection out of them. You can see it on this concept diagram. There is a catalog generator accessing different endpoint types, one of them being Sentinel Hub collections, second being generic stack catalog, third one, for example, being just the WMS endpoint of some public governance agency, where there would also be the concept of time. You probably have layers which have a time element. And all of this is unified for the EODASH catalog so that we have a uniform interface on our end to access it. And we also use stack extensions as a concept quite a lot, which are defined schemas, how the stack should look like in order to provide some value to the clients. For example, there is a render extension, which gives information to stack clients how they can render the data, or there is an extension for WMS links. For example, this would give you information that there are WMS endpoints attached to the collection, and the client can directly view them and use them with with no configuration needed. And the bottom part of the diagram is the two tools that we'll be using: the storytelling, which will come after me, and the EO dash. That is what we will be using to show the data, and that is what we will be adding the collection to. So that was the introduction to the stack and how our role is in it. So I will hopefully shut down the correct window, and will lead you back to the workspace. Your output now from the previous work is 2 data files. And if and they are private, they are within your workspace, nobody sees them. But this does not really play well with that we want to publish our data to the public. So there are basically 2 ways how in our workspace it is usually done. We have attached S3 storage to a same one for all of you for the workspace. And there is a tool called File Browser, which is a browsing interface for this. Currently, it's very empty. There are just the 2 output files, which are same for all of us, that were uploaded there. In order to interact with it, you can also go to the Jupyter Hub, which you were in, and see it on the root level of your directory. So there is a connection to the bucket, and you can even move your output if you made some personal output, if you change the parameters, if you produced a bit different stretch, for example, for your night lights, you would be able to place it there. So I will show it where it is. There is a folder called bucket, which is just the direct connection to the root of the bucket of that storage. So going there, I see the 2 files that were already uploaded there. If you want it, if you have some personal output, you can make a folder there with your username and copy the content there. It's not necessary, but for following up, the files are there. So the file browser interface has one functionality we will need in order to make our data public. For our workspaces, we usually set up a public folder or public subpath where we ask people to dump their data. Everything on that folder is public. For this tutorial, we did not set it up. We just have a concept of publishing the file for a certain amount of time, here a week. How we do it? So each file, when I click on it and go on the top right, on the info icon, has a way to show me a pre-signed URL. So this will be a public URL for 7 days that we will be using a bit later on. If I want to copy it, I will just right-click and copy link. So this is what we will get back to in a few moments. Now, the one tool I will need to introduce is a data editor. This is the main interface for contributing data for people in the consortium to the dashboard. If I go to it, it asks me for authorization. The same thing will be asked from you. Important thing to note, it asks you for permission to all your repositories. Why? Because the client itself will need to create a fork of the catalog and fork of the stories later on. So don't be scared. You can revoke the access if you are a bit scared, you are worried about privacy. But we, at the moment, cannot grant access to only repositories because they were not created yet. So it's a chicken and egg problem. So I will grant access to all repositories. So install and authorize. I need to type in my password. Hopefully you will not see it. And we end up in a content management system for our collections. We will first start a new session. A session is equivalent of a GitHub branch, but without the complexity of GitHub, without complexity of any code editor. But this will be our work stream, basically. Now we want to work on adding Nightlights data to the dashboard, or any data that you would create. So you can name the session however you want. I will name it BiDS'25 training, which will then appear as a name of my branch. It will take a bit. Hopefully this all works for you as well when you follow along. Now it should create a few things, fork of a repository, a branch, and so on. And we will see a new window where we can either create a new data set or edit individual files. That would be for working with existing collections, changing their metadata, and so on. So the main purpose why we do this is that we create a equivalent of a stack collection with necessary metadata in order so that your research or your work is findable. It has corresponding metadata for which satellite mission was used for it, which area it covers, which time entries there are, and so on. So I'm creating a dataset submission. That's the step we will do. We just need to name a file. So this is one entity. This is our one collection. I will just call it, for example, Nightlights demo. And be continuing via submit. This now in your fork created the actual file, a JSON file. We use a JSON format. Okay, this should go away. So let's take a look. Didn't, so let's refresh if that goes away, because I am already authorized. And at least we will see how our list of sessions looks like. So there is my training session. I can click on it, go back to my, let's say, work, and go to the collection that was created. We end up in an interface where we can really field by field fill in metadata, link to resources, link to actual files in our interface. There are a very small set of mandatory fields. That's just the essentials that you need for the dataset to appear anywhere. A name of the collection, identifier, and so on. And they are linked here or labeled with the red icon. So there is some work to do in order to have a minimum viable collection, even if it will be empty without any resources. And on the top right, there is a save icon, which is saving your work up until then. And below it, there is a reset content. So this reset icon, which will revert all your changes up to the previous save. If you messed up something, you can revert this way back to the last changed state. I will fill the few essential fields. That is the EO-dash identifier, which needs to be unique, not matching anything else which is currently in the EO dashboard. It doesn't have any other rules than that. I can just say Nightlights demo bits. Title is a human readable form, human readable name of our data set. So this would be Nightlights over New Delhi, because that's actually already concrete information that we produced. Description allows for markdown content. So this is the place where you would really describe your research that led to this indicator, describe methodology that you have used. You can even link external images, embed basically whatever raw markdown allows. So this is very flexible field. For me, I can tap into an existing collection in your dashboard and have a look at what is there in the description, and we can take it as an inspiration, for example, copy from there so that we don't need to write all the content. This will actually also let me talk a bit more about what are we actually now filling, how it will look like on the EO dashboard. So let's go there. I will just go to the dashboard and search for our version of the night lights, which is a global data set, and we just created a subset of it. Night lights in urban areas, and on the right side you see the metadata that we are just filling in. So there is some information about the satellite, sensor, which agency contributed the data, automatically generated time extent, so this is nothing we will be filling, and then the description. So this is really a markdown description of our data set, so we can copy that with the header as well. And in the rest of the fields, actually it's much longer than that. So I just copied part of it for now, doesn't matter. There can be information and links to the data providers, for example, where your lower level data came from, and a link to assets, which are again automatically generated from everything that you will contribute in the data editor, and the possible links. These are not all the fields that are in the data editor, but most of it. And I also want to show how this collection would look like in a Stack browser, which is probably the most commonly used web client for browsing Stack collections. It's also open source, same as our client, but it's probably the interface that you will see more. I'm now actually following the playbook that we linked at the beginning, so I will show where I'm taking the link from. It is from the fourth link, so our Stack catalog via the Stack browser. And here I can basically do the same workflow. Have a look at the night lights collection and see the metadata, see the temporal extent, see the license, see the description here, see the legend asset, provider, metadata, and so on. So same information visualized in a different way, but still needs to be filled in order for the collection to be actually described properly and findable. So coming back to the data editor, this is the answer why we do all this. Yeah, go ahead. Mm-hmm. Not at the moment in this workflow. Mm-hmm. The catalog generator anyway generates its own items and its own collections. So the flow to use what you already produced would be probably not use data editor, because that's a really schema-based content management system, but you would work in a code-based manner with a script, which would be creating the same structure for our collections, but you would fill this information from your JSON file. These are... Yeah, exactly. What you could also do is completely skip this step of what we are doing and create the EO- catalog with its collection structure from your existing items. And that is documented on the EO-org ecosystem, which are necessary fields for collection, which links it needs to have, and so on. So going back to the description, I would add some description and try to save it at this point, because all the mandatory fields should be already filled. You can see that this now starts preview generation. You see it here on the right, which means there is a GitHub action actually trying to build our catalog so that you could preview how it looks like, if it even ran through, if the schema was correct, if the file actually renders anyhow. It will not, because we did not reference it yet. But each saving of a step will, for all of you, start generating a preview. But we could now have a look at the next properties that we can work with just very quickly. For example, agency is a field I can optionally add, which will now appear in this tab on the top. And I can add entities of agency. So I will say here, the JAXA is my source of information. I can also edit information about data source. So I'm going to the data source, and I can add that it's actually spaceborne satellite, linking that, and I can say that the satellite is it was the Suomi NPP for our night lights. So this would be the workflow, how to actually label your data in a schema that's been already generated for you. I can save it. Now the most important part is, in our workflow up to now, we generated a cloud-optimized GeoTIFF file, and now we have a public URL of it. This is done in the Resources tab. So this is actually interfaces to the data providers where your data is hosted for us. Now, the type of the resource is here on the third from the bottom, cloud-optimized GeoTIFF source. So this means there is no API in place. We did not set up any. It's just files lying somewhere with some time information. It has some mandatory fields though, so let's have a look. We have an optional link to a style, which we will talk about a bit later. We have an option to draw a bounding box area where our file is probably located. This is not done automatically because each file can be somewhere completely else. So for us, we will just say it's roughly somewhere where New Delhi is. And we need to add time entries. So this corresponds to the actual item. We know that this file is from multiple years composite, so we'll just put one of the years there. And the 1st of January of that date. Here we don't really have more on-point example than that. And we add an asset. For getting the asset, I will go back to the file browser in a new tab to get me the pre-signed URL. It's going to be same for all of you as well. And copy that link for our input here into the file column. And identifier can be anything. For us, it will just be file 1. It needs to be unique, but for our use case, it doesn't matter what it is. And I can save it. So this will again trigger a generation of a catalog that should take a bit below 1 minute. And in the end, we should see it here in this preview on the right. We can have a look what is there now. There is already an entry for the collection. So this under the hood creates us a catalog with one collection, with all our metadata, and a simple filtering interface where we can filter by theme or by name or description. The theme is something we didn't actually fill, but it would be one of those 8 themes that eodashboard.org has. So if I went there now, I know that I would not see the file yet because the preview did probably not run yet. If we want to be sure that the latest edit is actually propagated and it runs through, I can go to the actual GitHub equivalent of what we are working on. And that would be this button on the top left, view file. So these are the changes we are actually working on and what we have added until now. It's a JSON, so we don't need to edit it manually. That's why the interface is there. But we see that there was activity 1 minute ago, and I think we should also see the GitHub action that was running. Oh, I don't see it here. So it would be in actions, I think. Okay, no, it's in the source. I would see it in the session itself. Going back to the session itself, I wanted to get to this interface, which opens me the level of my session. And we can see that this, under the hood, is already a draft pull request to the official catalog. And that's where the actions are running. And I see that the last one already successfully ended. It didn't fail. And I should be able to see the preview now with an updated content. And what I want to see is the file rendered on a map. Why? Because the file that we created already is styled. It's an RGB 8-bit 8-bit cloud optimized geotiff. So it doesn't need any style being applied. And we see that it is true. We generated cloud optimized geotiffs that is styled for a certain tile on the map. And for all of you, after getting to this step, you should see such a preview with the map buttons, and important part for later, the storytelling. You also see the loading of the storytelling information, which means you will be able to copy this and paste it into the storytelling editor to put the map view of this collection there as well. So that was one part of the flow without the style. Our data are already styled here. But we will also talk about if your data is not RGB 8-bit, which was the case for the land surface temperature. If you remember from the notebook, it was actually a temperature in Kelvin that was actually even scaled by 0.02. So it's not a straightforward information that you would put on the map without any other configuration. So we will try to create a new file and just work in the same session. We don't need to create a new one there. So I will just create a new dataset submission. The way to do it is in the top right in the automation. So we are going to the land surface temperature. So we name the file the same way. Few essentials we need to fill in anyway. So the name is there, EO-dash identifier we need to fill. The title needs to be filled in. We will fill in GCOM CLST information for July 24. That's what we worked with. We can try to save it. And I will talk a bit about the styles because ideally, and that's something we are working on, the whole workspace would allow you to work with the styling of the data in this interface. It's still work in progress, so not shared in this tutorial. But the workflow would be, there would be a new field which would really work with the preview of the data style. Here we need to do a bit of a workaround, and that is to create the style manually in the data editor itself. So I will not use an automation, but I will create a new file which I need to go a level up. Actually, I should have gone to the browse files. That was the way. Yeah. So I'm going to the Browse Files tab and creating, for example, in the root, for simplicity, a new file with a JSON suffix. That will be our style definition. I will talk a bit more about what needs to be there, but for now, style.json is good for us. No, create new session. No, that's not what I wanted. I wanted to create a file. We will deal with it. So let me check if I can do it the proper way. Going to the original session which we were working on, bits training, and adding a file. So adding a file, new one. Edit in current session. That was what I should have done. Yeah, missed that on the big screen. So we are going to edit that in that session where we work. It's going to be empty, but and it doesn't have any schema, so it will not limit us with the fields as we saw before. It's just free content. And now I need to talk a bit about what ways we have for styling our data. First, going back to the tutorial materials, we, for vector data and raster data, use a language which we did not develop, but we extended it. OpenLayers, as our main map library, uses a style called flat style for defining how to render vector data, how to render raster data. It has a complete grammar for allowing even mathematical operations on the data and styling them. Here, this is our reference, but if you wanted to go really from scratch, we have a subset of, let's say, most commonly used styles for data that we have already encountered on our eo-.org website in the documentation section. So we will navigate there. We are going into content integration and data configuration. So styling simple vector data could be as simple as adding a fill, adding a stroke, and some width. This is a very simple example, but we work with raster data. Here, the example is already a bit more complex. I will talk a bit what the aim was here. There are two files compared to one in our case, and that is, one of them was solar irradiance. Second was settlement distance, a distance of a certain area from a nearby settlement. And we use both of them in the visualization. First, the solar actually creates the style part, so the actual conversion of values of the raster into a color in RGB. The settlement distance is used as a filter. So show me only areas which are less than 5,000 meters from closest settlement. And this was a use case, for example, for showing or letting people browse through areas for a solar plant that they could build somewhere which has some regulatory base for it. But the language that we use is seen here. The color part, that's the standard OpenLayers style. That's nothing we modified. What we added, and the variables as well, the variables are part of the style. What we add on top are UI elements as this whole part. So this defines us a slider from min and max for a certain variable. And that one we reference in the style via the variables notation from here. So we will try to reproduce that. Our goal now is to have a style that maps the land surface temperature converts it to Celsius, and creates, for example, a magma color scale for it. So this is the language that we'll use and how we will do it. Here I'm again taking one link from our tutorial playbook. The final example or final result should look like this. We have a filter where we filter out node data. So whatever is 0, which is usually a node data field, for us it is, we filter it out, so it will be transparent. Otherwise, we need to convert our data with this scaling factor that is just part of the data definition, so divided by 0.02, multiplied by 0.02, and then we subtract the conversion from Kelvin to Celsius. That's the mathematical operation with the band to fuel into the linear interpolation from 0 to 60. So this is really Celsius values mapped to some RGB range. How I got this RGB range? Usually, or ideally, for our final version of the style editor, you would just input Magma or BiDS', something you already know from other, for example, Python environment, in Matplotlib or other libraries. They use this type of definitions. Here we need to create it manually. So we did not develop, but we use a third-party helper app, a small one for this tutorial, which allows us to list a number of categories, list one of the 4 color scales, and we get RGB values from there. And we can, this way, we would get the RGB values for our style definition. So this is the style part. The next is the JSON form. So we have a slider for the temperature, just limiting the minimum and maximum for which we will be rendering our colors, because the variables min and max are defined here. The variables can also be named differently, but they need to end with min and max. So this is the JSON form part, defining our UI fields. And last part, we also can define a dynamic legend for people using the dashboard that you will produce to have a reference of what is actually my min and max that I'm looking at. So this one is also updated dynamically, but the definition is here from 0 to 60. And the RGB values are really the same, taken from the style definition. So I will copy this for later reference, but going back to the data editor again. Okay, here we go back to the data editor, to our session. And this we will put into the style, and for all of you that should work the same, but you will all have a different, no, I need the actual content, not the URL. So pasting really the JSON style that we had, saving it. And here, because we are working with GitHub underneath, we will again need the GitHub URL for it. So I can open this as a new tab, going to the GitHub version, taking the raw button, and taking the URL. So this is again publicly hosted URL on GitHub that we can use in the collection definition of our lens surface temperature. So lens surface temperature we have here. So we will add a new resource. That's the end goal where we want to stop. We will have a cloud optimized geotiff source again with the mandatory properties. It's again for us here area of New Delhi. Although our data is global, the ones that we have in the ones that we downloaded in the Jupyter notebook, and we will set the time as 1st of July. That's where, well, the data is for the whole month, but for us, we need one time entry. We can finally add the style here, and as I already copied it, I will paste it there. So there's the style, and we need, again, a reference identifier and a file. Identifier can be anything. File we need to get from a file browser using the same principle we saw already before, and it is the pre-signed URL. So a public validity, a public link for our data for 7 days, and save. Ideally now we will see a styled file, styled data all over, zoomed to the area of New Delhi, but global data with the actual sliders to control the visualization, to let the user play with it on the map. And it should take us around 1 minute to get there, and that's where I will then wrap up. Just to add something which already was said, but I want to emphasize on that again. The technology underneath, the dashboard, the catalog generator, all this preview logic, that's all open source. You can, for your data, basically create the same functionality we do now via GitHub. So not the whole interface of EUX app is for the tutorial, but the style, the dashboards, everything you can deploy via GitHub pages, for example, yourself. And there are template repositories in the EO-Dash organization which let you do that, hopefully with one click or a few of them. So it seems we have a refresh here, so I will have a look if our data set is there. So there is a new entity, the land surface temperature. It is zooming me somewhere, and I am getting a styled version of, here in this case I chose magma, I think, and we are basically masking out values above 60 and below 0. So you see that even, for India that would be roughly same. Here the area, even in Iran we have somewhere temperatures over 60 because it's in the black part of the spectra and even beyond that. So this would be the final where we wanted to get. Hopefully most of you got there as well with me. Are there any questions before I pass the word further? If you think of a question later, you can always find us. Go ahead.
In the resource, the only thing that, Sentinel Lab resource is the only thing that is not open source because it's from the synergized Sentinel Lab, yeah?
So Sentinel Hub resource is an abstraction over the Sentinel Hub collections. So we anyway use their Stack API, and we get the time entries from there, and we build the WMS links from there. In order to use Sentinel Hub, you need to have a paid account. We, for the dashboard, use one instance, and but the technology behind the WMS links and so on could be used for any other WMS service. What is a completely open source project is what's running with the Veda resource. So that is using EO API as a software stack. Also producing XYZ links for visualization based on stack collection. So this is something you would be able to run and deploy yourself without the proprietary part of it. And that's what we are also now deploying within our EOX app workspaces, the EO API stack, but not part of this tutorial because it would be too long. Exactly, yeah. And also one different addition that we didn't show, but Anka showed at the beginning, Sentinel Hub allows you to do the statistics part. So to really query the images in a time stack and get some time analysis over it, which is also part of the Sentinel Hub resource. not part of usual WMS endpoint that would be out there. Someone would. Yes, and within EO dashboard, we have an instance that we use, yeah. Yes, so the concept here is we provide a workspace for the tutorial. Then in a few days, the tutorial workspace is gone. But you can get the workspace for your research and mm-hmm.
Then my dashboard will be paying in my account of Central Lab,
Yeah. Any more questions? Then I invite Sarah to the stage.
Hello again. So if you have access to this playbook, please go to this URL, which will lead you here, because this will serve as our companion to build this story. For now, we have a turtle, but I expect at least 20 more animals here, please. And it's really useful that you connect to these Google Docs, because this will shorten the time we have, because I already prepared some content that you can simply copy-paste and get your story going. So we have 6 connected. And I will also advise you to split your screen into so you can see both things. Not necessary, but I think it will be more practical for you. I will wait a bit more to follow the story, because we are actually creating from scratch a story. So tinyurl.com/eo storytelling, okay? In the meantime, I will show you on what we are actually doing. So recap, on part 1, we created indicators. We also generated some statistics on indicators to have a deeper insight than just visuals. On part 2, we learn how to ingest this on the dashboard. And this is what will allow us to create a visual, interactive site like you see, a dashboard, where you can navigate through these nice satellite images and indicators while adding information on it. So we have 16, it's already a good number, and I will just increase for you to see. This is a long version of our story, so we will not build a story as long as this one. And you can open yourself if you want this, it's the second link. But I will show you, it's not, for the purpose of the tutorial, it's not necessary, but I'll show you a longer version of this story. We have a header, and we have also this navigator, where each of these, we decided to organize as each of them is dedicated to a use case. In this story that was developed is bigger, and I will show you, I will increase for you also to see the potential. We are focusing in this story about urban health in megacities, with the focus on New Delhi, the capital of India. And in this long version of the story, he also add other indicators are available on the EO dashboard, just to support the storytelling part. So for instance, in this first one, we didn't use this indicator, but it's to show the meaningfulness of the story. So we are plotting here a map with a gridded population, and we talk about where this indicator comes from, and we highlight the high density of India, and you can see in the panel we had this information and also pictures to illustrate the story. Then we move to urban heat waves, and once again we highlight where is this, what we are looking at, how to interpret this image. We mentioned the satellite mission. Of course, it is always up to you. What is your goal? But if it's for educational purposes to teach people how to look at satellite data and what they are seeing, what they can infer from it, this is a very nice option. And you see, you can move from, this is a map tour because we are moving throughout the map. And here we pass to the air quality with the tropomy on board of Sentinel-5P. We mentioned the case of high concentrations in New Delhi in December, and then you have a focus on Gurugram, and here we included the graph generated. Then we also add another satellite that was not included on part one, but just for visual purposes of Sentinel-2, optical satellite, just to help build the story around where pollution, where NO2 might come from. Then we jump into human activity that can be perceived with what happened with when looking at the nighttime lights during lockdown period, and we add legend so people can interpret easily what is the meaning behind it and what one can assume because looking at the different colors. And we move to this, the very last one, the GRDI deprivation index, and also the VNL slope. And then we zoom out, and we also add here just all the reference to the data sets to support for someone, for instance, that is not so used to satellite data, might be overwhelming all these missions. So we also can include a table so people understand what is a mission, how to see it on EODash, and so on. Now let's build a very trimmed version of this story. So you go back to the EODash, and you come here. And now we are going to click on the narrative editor. And we create a new session. This is like Lubu mentioned, it's like it's a branch on YouTube without, sorry, on GitHub, not YouTube, on GitHub, and but without all the complexity. So let's call it BiDS' narrative. I create the session. Let me know if I'm going too fast. And when I create a narrative, and I'm going to give an idea, this can be urban health. Submit. And whatever I built here, it's going to generate a markdown on GitHub. So once again, this erases all the complexity for people that are not so used to GitHub. And with this markdown, then it will be ingested on your dashboard, which allows us to have these stories already all formatted. So now we go back to the, exactly. So first things first, we need a header to our story. So in the narrative editor, you have two panels. In this one is when you develop your code, let's say your markdown, and here you can preview just like in the data editor. So one way to create each section on this left part is either writing here, but if you're not so familiar, you can always click on the plus and then select what you want. So in this case, I want a hero image, which is what will go on the header, and I add the section. So this is, I will remove this. And now I want to, this is where I'm going to start using all the content here. So I have the header image, and I want to use this image for the header because it's India, or in this case, New Delhi, and it helps paint my story, let's say. And I can change here. And changing here the title, I can put here a title. I'm typing with one hand, so I'm very slow. So I will keep with short things. Urban health. And now let's say it's subtitle. Satellite-based perspective in India, in megacities. Okay, we have a header. This is how it looks like. Okay. Now, I want to create now one of the indicators, and in this case, let's follow the same workflow that we did with the part one. So let's start by ingesting the nighttime indicator that we created. But first, let's add introduction to our text. So to create a text, a section with containing text, you once again click here on the plus, and then you add text. It will appear here, and then you can add the content as you want. So this can be our introduction to the story. Introduction. And then you can come here and just copy-paste into your first section, which is just a text. So here we are mentioning, setting the scene. And in order, for instance, if you want to create bold text, you can either select, let's say, New Delhi. You can either select and click here, or simply do yourself by creating these elements. And if you are not familiar with this type of writing, there is this storytelling that you can find here. In the storytelling elements, it is a cheat code for you to know how to write all these little elements: bold, italic, add sections, add map tours, and so on. So we have the header, we have introduction. Now we are going to initiate with the first story on the nighttime lights, how COVID impacted the activity as perceived from space. So here we can open a new section, and let's put a text again. I'm copy-pasting here the text already made about nighttime lights, and then we can put a text, and then we can put a more text to introduction this. So in this text, we have introduction to this. And now we can add one simple static map. We can also add an image, by the way. Just removing this mock-up text. and adding the image that we have in our document just below. This is the legend. Okay, so now we are going to add our first indicator. You can click here, it takes you already to the dashboard where you can, as explained to you by Lubo, you can grab the information, the layer. Please let me know if I'm going too fast, of the indicator. One important thing, wherever you see here, when you collect this information from here, whatever you see, it's how it's going to be plotted on the dashboard. So if I want to have a focus on New Delhi, I will zoom in on New Delhi. And I'll put a bit, I know that the text might appear in the left, so I will put it slightly to the right, zoom to see the colors. And now I click here on the little map, and I just want to have a single map. I'm not going to do an interactive map where I walk through, so I copy, and then I move to my narrative editor, and I passed it here. Let's see how it goes. So let's try another way. Can go to your dashboard. You open the dashboard, and then you look for the indicator you want. In this case, let's go for nighttime. I click here. Same thing. I go to India. I zoom in to New Delhi. I zoom, zoom, zoom. I put how I want it to appear on my story. And I extract. Let's see if it works this way. Okay, and I have my map there. So now we move to the second use case, which is, let's see. Okay. The second use case, it is air quality. So once again, let's click on the indicator to extract the map. We can select the indicator, which in this case is NO2. It's already here. We do the same thing. We zoom over the area of interest. And in this case, if you recall from the first part, we were looking at the concentrations of NO2 in the end, towards the end of 2024, in close by New Delhi, in Gurugram. So here we can select the exact same date, or let's create a map tour where you go from one date to the other, and we can select a date in 2024, which in New Delhi, it is, as you see, very high concentrations of NO2. So in this case, we want to add a map tour. So we go back to the narrative editor, and instead of adding a static map, you will select now tour. And let's call it air pollution. So once again, to recall, every time you see double cardinal, it will appear as one of these navigators, and we are dividing by use case. This is why I call it air pollution to address the use case too. So on the map tour, this initiates the map tour, and now I'm going to add as many layers as I want. In this case, let's do look at December in New Delhi, and then November in New Delhi, and then December in Gurugram. So I go back. This is a lot of back and forth. I go back to my indicator, and I grab the map tour section. So it's the bottom one. I copy, and I go on the narrative, and I replace. This is my first layer. And let's call it December, so I don't forget what is this referring to. December in New Delhi. And here we can put the text letter. We go back now to the EO-dash. And now I want to keep the same look, but on a different date. So December, I copy another layer of this, and then I add as a second layer. And let's add one for November. That was a particularly bad timing year, a particular bad event on pollution, more in New Delhi. If I recall, it was this date. Okay, let's leave it like this. We can put it, and then we build a story around it. So I extract this layer for November, and then I go back to my narrative editor, and I add my third layer. So this one is November. And the other one, I will remove the middle one. And now let's see how it's going, how it's looking so far. So, okay, December, November. Makes more sense to invert these dates, right? So let's do like this. I will grab the entire layer of November. I cut. And I place it here. And then we can add some text. So let's see, I go back again. We have November, and then December. Okay, now let's go grab a bit of text that is already prepared. So for the first layer, we can use this text and also copy the image here, because it will look nice as you see. So copy all the way until here without the cardinals, because these are the title within the panel. You copy, go back to the narrative editor, and we replace underneath November. Let's see how it will look like. Okay. You see here we already are including the interpretation of the image. And but if you remember the particular bed date and location was December in Gurugram. So let's use the plot that we generated on the first part of the tutorial that's already included here. And we copy paste and we add and replace everything here. So let's see how it's looking. It's very useful that we have this preview because we don't get lost in all these markdown format. So let's see how it's looking so far. We have this, the nighttime, the static map. We have a map tour of air pollution, and maybe it would be nice to have some text before these two. So let's add here something. It can be a text, and here we add an introduction to the use case. Just to be less heavy visually speaking, and we can put it is after this. Let's see where it is. Here we have the map tour of air pollution, the map, and okay, we continue to move to the next use cases to have the time. And in the end, I will share with you the entire already made markdown, so you have the full story. So let's go to the next section, which is the heat waves. Same as usual, you open the dashboard or the indicator. Also, it was the one that Lou was just explaining how to ingest. And this one is already nicely zoomed in the area of interest. Let's zoom a bit more. We copy again. And before we adding this map tour, we create a section for a map tour. So we click here, tour. This will be called heat waves. And we add this section. The indicator, the layer, I already copy paste, so I can copy paste it here. And let's see, it will appear here. So for the text, let's see. We are here describing once again the concept of a heat wave, what happened, and plotting the graph, the image that we generated with the heat waves. Let's see if it goes. Okay. And we move to the final use case, which is the deprivation and poverty index. So once again, Are you guys, I hope I'm not being too fast. We are 10 minutes from the end, but I will share all these markdown. You just can copy paste there, okay? So in the second layer, for the deprivation, is the same thing. You can go to the EO dashboard. You look for the indicator here. I think it's also under economy. And I will just plot one. And we can, again, zoom in. Copy as a map tour. We go back to our narrative editor. And we add this as a tour map again. And this, let's call it vulnerability. Vulnerability. And the final, and now I replace this layer with a layer that I just copied. And I add the text here that I have as support. Say, I can just copy paste this one. And I replace just the text with also the images that we created. Okay, perhaps it's a bit messy right now, the follow-up, but you can come here and simply, if you scroll down, you have the entire story here. So I made you go through step by step, but here you have the entire story that you simply can copy-paste all at once in your Markdown. Copy. Can you see on screen? Okay, so I copy it all and I will just simply replace and put it here, and you'll see that the entire story, the long version of the story, it's all in here. And in this case, you also have added another section that we did not create it, which is a table to show the data references, and also you can include notebooks. For instance, you can if you want, once you tell the story, if it's your goal for educational purposes to teach people what the research behind it, it can be also nice to add a notebook. So let's just add to at the end of the story. And we will conclude with that. Let's see, finally, adding a notebook. Okay. just copy paste it here, and we can put at the very bottom of our story, and it will appear here. And if you want to share this, you can save the story that you created. And if you want to share this outside with someone that has no access to GitHub, you can get it from GitHub, a link that is automatically generated, and you can share the preview of that with someone that needs to, for instance, proofread the story or see if they like how it goes, and then you can simply share without issues of access. Then this was already automatically generated. Then you select the story that you created, and then you can simply click on it and pass the link and send to someone, and in this way they can preview the story without access to GitHub. And I think we concluded the narrative editor. Any questions? I hope it was not too fast or not so cumbersome to follow. Yeah, it's commentable. I can put it editable. So should I make it editable or? Okay, so I leave it as a commentable.
In all the scenarios you are covering now, all the stories you are covering, you are considering that all the data is open and there is no protection, no security.
Yes, yes. So
Then you didn't have any user stories where you need to use sign URLs and
no. BiDS' is the interface to all these dashboards that allows, it's like a window. It, thanks to the Stack catalogs, it's able to grab the data sets and visualize them. So it's not stored on BiDS', but through this architecture, it allows to grab the data and plot.
Yeah,
So,
I'm thinking more in the stack catalog, you can have information about the security involved to access it. But you didn't cover yet any of these use cases of adding a security layer on top. No. Okay.
So we are working on actually allowing to work with authentication extension in Stack, but none of the data.
It's all right. Everybody's very good work.
thanks.
Thank you for being with us today, and we hope you enjoyed it. And we're open for questions whenever you want to reach us.
I put this on the
it's a complex case. Probably you're not there yet. But the thing is not use my account or my Sentinel account or my application when I am accessing the resource of my story. But the person who is reading the story is putting their credentials to access the data. Yes, it's for example, if I go to the Sentinel, if I use my credentials and I put it there, I'll obtain this kind of it's not there yet. It's not a critique.
It's in development.
I do it like this, huh? Better, I go like this. Okay, talk to you, we'll see each other.
Maybe just one of the configurations, not all of the options, but like you have one default and then you can just drag it in.
I would need to talk with Sylvester, maybe, and he would probably catch up on this idea. I'm not sure how that would work.
In the notebook, it's a call development. We could also generate an accompanying JSON, for example, that we uploaded as a resource in the data editor so that we don't have to manually add this field. Plus on the storytelling as well, it's the same thing since in the notebook we have the marked up cells that could be exported